So today we're going to learn some basic stuff. Introduction to systems of linear equations. Introduction to system of linear equations. Okay, so definition. What is a linear equation? Now, definition of a linear equation in n variables. N variables. A linear equation in n variables, x1, x2, x1, x2, x3, xn has the form a1 x1 plus a2 x2 plus a3 x3 xn equals b. So we have this format: a1x plus a2x plus a3x plus an xn. Assume we have n terms. Okay, the requirement for the coefficient a1, a2, a3, an are real numbers, and the constant term b is a real number, and of course the a1, the number a1 is the leading coefficient. And x1 is the leading variable. Okay, be careful. For all the coefficients a1, a2, a3 until an are the real number. That means it can be any numbers like 0, 1, 2, 3, 1.2, whatever. But for the a1, since that guy is a leading coefficient, shouldn't be 0. Okay, a1 couldn't be 0. If there's a 0, this term gonna be disappeared, right? So a1 shouldn't be 0. That's the point. Now let's take a look at the typical and example. The first example is here. 3x plus 2y plus pi z equals square root of 2. Okay. Now, based on definition, could you tell me, is that equation a linear equation or not? Is that a linear equation or not? So the first things you can tell, A1 is 3, A2 is 2, A3 is pi, right? And the B is square root of 2, right? So we can tell A1, A2, A3, they are both real numbers. Pi belongs to real numbers too, right? So real number, real number, real number, real number. Square root of 2 is an irrational number. Of course, that is real number, right? So all these three belongs to real numbers, and we also have x, y, v that corresponding to x1, x2, x3. Okay, so that is linear equation. Okay, linear equation. Now let's take a look. B. E to the power x minus 2y equals 4. Is that equation a linear equation or not? Yes or no? Yes? No. The answer is no, because this term, that is not a linear term. You couldn't split e to the power x equals something times x. That is not a linear term, right? Linear term should be a constant times a variable, right? Constant times a variable. That is exponential function. It's not a linear term, right? Clear? Exponential function. So since this guy is not a linear term, not a constant times variable, so this is not. Now let's take a look, another one. How about this guy? Is that a linear equation? Yes or no? Sine x1 plus 2x2 minus 3x3. Is that a linear term? Sine x1, is that a linear term? Yes or no? No, that's right. Because sine x couldn't be split into a constant times variable, right? Always about a constant times variable. And here, sine x1 couldn't be split into a constant times variable. So this guy is not, okay? So it's not. Very good. And the last one, okay? Think about it. Is that a linear equation or not? Is that a linear equation or not? Who can tell me? Yes or no? Yes. Why is that? Because sine pi over 2, that is a real number. Sine pi over 2, you input the sine pi over 2, always give you a numbers, right? Real number. E to the power 2, that is a real number 2. If you input e to the power 2 in your calculator, always give you a number, right? Give you a number. So that is a real number. All the coefficients are real numbers. And the constant term b is a real number 2, right? And all the real numbers times a variable, right? Times a variable. So that is linear algebra, linear equation. That is linear equation. Okay. Understood? Any questions? No question. We're going to continue. So a solution of a linear equation in n variable is a sequence of n real numbers. N real numbers S1, S2, S3, Sn, that satisfy the equation. The equation when you substitute the values x1 equals s1, x2 equals to s2, x3 equals s3, xn equals to Sn, okay? To describe the entire solution set of linear equation, use a parametric representation, okay? To describe the entire solution set of linear equation, use a parametric representation. Okay, so today I'm gonna address another one. What is parametric representation? Okay, representation. Now let's take a look at an example. Example 2. Solve x1 plus 2x2 equals 4. How to solve this guy? How to solve this guy? And as we can see, for this linear equation, we have two variables. So since we only have one equation, normally if you have two variables, you're supposed to have two equations, two unknowns, two equations. That's the rule, right? Otherwise, you couldn't solve it. However, here, if you use parametric representation, you always can use one variable to express another variable because we have one equation. Now let's take a look. So we just move this term to the right-hand side, 2x2. And then we're gonna get we get x1 equals 4 minus 2x2. Okay, so now we have one variable to express the other variables. Okay, we use x2 to express x1, and we can let what? We can let x2 equals, for example, s. Okay, for example, s. S is whatever values. Then x1 equals 4 minus 2s. Okay, for s. So basically, the solution for this linear equation gonna be what? We're gonna be this guy. x1 equals 4 minus 2s, x2 be s. Okay, and for s can be any real numbers. For example, s can be a 0. If s is 0, then x2 equals 0. And plus to here, we're gonna get x1 equals 4, right? And if s equals 1, okay, x2 equals 1, then we plug in here, we're gonna get 4 minus 2 times 1 gonna be 2. So x1 equals 2. So how many solutions for this linear equation? Infinity, right? We have infinity solutions for this linear equation because you can pick whatever s is, right? Whatever s. As long as that is a real number, it can always be, we can always find the solution, right? Find the solution. So we have infinity solutions for this linear equation. And of course, you can pick any other letter to express these parameter, okay, parameter. You can pick a t instead of s, right? Whatever you want. Another example. Example 3. Now, solve 3x plus 2y minus z equals 3. The same thing. Here is the linear equation because we have 3 variables. However, the coefficients are all real numbers, right? Are real numbers. So definitely that is a linear equation based on the definition. Now I'm gonna use parametric representation to express this equation system. So the first things, I will always keep one variable at the left-hand side. So we have one variable. For example, I keep 3x to the left-hand side and move these two terms to the right-hand side. So we're gonna have okay, and I always want to keep this coefficient of x as 1. So we divide by 3 for both sides. And we're gonna get distribution. We get this expression, and we call this one is we use two variables to express the other variable. Okay, here we use y and z to express the x. Now we're gonna use a parameter to represent the solutions. For example, since here we have two variables, right? So we let y equals s, okay, z equals t. We have two variables, so we need to define two parameters. Let y equals s, let z equal to t, okay, parameters. And we're gonna have x equals right, and the solution for this linear equation can be written down as that's a solution. And for each s and t, we can find the values for the y and the zx. For example, if I pick s and t are 0, if I pick a value for s and t, I pick 0, gonna be y equals 0, z equals 0, x equals 1. That is one specific solution for the linear algebra. And of course, you can pick s equals 1, t equals 2, you plug in, you're gonna get another solution. So that means we have infinity solutions for this linear algebra or linear equations. Okay, linear equation. Understood? Do you guys understand how to use parametric representation to express the solutions? Understood? Very good, very good. Now I'm gonna give you guys an example. Let you guys try it. For example, now use parametric representation to express this equation. You get it? Okay. Now I'm gonna solve it. So for 2x minus 3y equals 4, we keep the x at the left-hand side. We're gonna move this term to the right-hand side. We're gonna have 4 plus 3y. And then we divide it by 2 for both sides. So we're gonna get 3 over 2y. Okay, 3 over 2y. And now we're gonna pick. We let y equals t, for example, the parameter t, and then we can get what? We can get x, plug in x. Okay, so basically the parametric representation gonna be x, y equals t, okay? And for the t, it can be any real numbers, such as 0, 1, 2, 3, whatever you want. So for this equation, we have infinity solutions. Now let's try another one. Try the example. Now I give you more variables. For example, I give you x minus 2y plus 3z equals 9. Okay, try that again by yourself. Did you read the news? The hurricane is coming. Are you ready? We are pretty safe. We are in the center of the Louisiana. The audio gonna be terrible. Yeah, the next one. We are in a safe place. Okay, we're gonna check the news from the check the email from the chancellor. If he said we're gonna cancel this class, then cancel it. You guys should be happy if we receive such an email, right? Okay, anyway, so let's solve this problem. Of course, we can use same strategy we learned before, just move these two terms to the right-hand side. So we have 9 2y minus 3z, right? And then we let y equal to t, z equal to s, for example. And plug in, we're gonna get 9 2t 3s. And basically we can write down is this way. So that's the solution of this linear equation. Okay, I'm gonna give you guys a little bit of challenge. I change it a little bit. What is the solution for this linear equation system? Try it by yourself. Think about it. Now I just change it a little bit. I just add z equals 1. Okay, give me the parametric representation for this linear equation system. Have you heard anything from Lawrence? I haven't received any email, anything. I shared him several email. He never respond.
He's from last time.
Huh?
Did he finish your class?
No, he didn't. I tried to contact with him.
He's not in any of my classes.
What happened to him? Some bad things. Do you know any friends of him? I tried to contact him. I get no reply. I don't know what happened to him.
Did you graduate?
I don't think so. He still has several credits to finish. Okay, so good. Okay, let me do it on board. So here, basically, we have two equations. And we get one unique solution for the z. Okay, so what are we gonna do? We just need to plug in the z, right, to the first equation. Do the substitution, z equals 1, right? Plug in, we're gonna get and then we're gonna get what? X minus 2y plus 3 equals 9. And we move, keep one variable here and move everything to the other two terms to the right-hand side. We're gonna get 6 plus 2y, right? So 3 gonna be -3, 9 minus 3 is 6. Okay, so then we have the variable y here. We can pick y equal to t, right? T. So that means x equals what? X equals 6 plus 2t. Yeah, 6 plus 2t. And that means what? We have solution or parametric representation is what? Is here. Yeah. Yeah, I already defined that z equals 1. So what are you gonna do? Just plug in back, and we get x equals 6 plus 2y. And then we can pick the y, and we're gonna get x equals 6 plus 2t. Very good, very good. And I'm gonna give you guys another one. I change a little bit. This time I change. I put another condition, z equals to 1, y equals to 2. So try it by yourself. You good? Okay, very good. So we do the similar things. Here I already define the z equals 1, y equals 2. What are you gonna do? Just plug in to the first equation. And we're gonna get what? X minus 2 times 2 plus 3 times 1 equals 9. And we can simplify this guy, -4, -1 equals 9, x equals 10. X equals 10. And the solution for this guy can be written as x equals 10, y equals 2, z equals 1. That's it. So we get a unique solution, right? Unique solution, just one solution for this linear system. Okay. So if that's not a unique solution, you can use what? You can use parameter like T or S, right? T or S. And that means you have infinity solutions. Infinity solution, or we can call it as parametric representation to express the solution. Okay, that's it. Now I want to go back a little bit further because some of you may forget the college algebra. Let me give you a 2x2 linear equations. So 2x2 example 4. X plus y equals 3. X minus y equals -1. How to solve this 2x2 linear equation? There's two ways to solve it from your college algebra. The first way we call the elimination. We just let, for example, I let x equals 3 minus 1 from the first equation, and then plug in this x equals 3 minus y to this equation, right? And we get one variable equation. We're going to solve this equation, and we're going to obtain the value of x. After you got the value of x, you're going to plug in back, get the y value. Okay, that's a strategy. The second method we call elimination. We basically use the property of these two equations. We do the addition or subtraction to eliminate one variable. For example, for these two equations, we can see the coefficient of the y is 1, right? And the second equation, in the second equation, we find the coefficient of y is -1. So what are we going to do? We do the addition. So we x plus y plus x minus y. Okay, so x plus y plus x minus y, and 3 plus -1 going to be 3 minus 1, right? Just add these two equations, x plus y add x minus y, 3 add -1 going to be 3 minus 1, right? And we can see y -y cancel out. That's the purpose. If we do the elimination, we'll always try to eliminate one variable, right? Because here we can see 1, here's a -1. We can add it together. If that's not 1 -1, you probably need to multiply on coefficients in order to do the elimination. Okay, so here we have 2x equals 2, and we can solve it. X equals 1. Okay, x equals 1. After you get x equals 1, you can plug in back to the first equation. For example, 1 plus y equals 3. and you're gonna get y equals 2. So the solution set is 1, 2. Okay, so for this linear equation, we can write down the format 1, 2. Okay, 1, 2. X equals 1, y equals 2. That's the solution. Okay, now we also can draw a picture, because this is a linear equation. Linear equation represent what? Represent a line equation. Have you learned the line equation from your college algebra? I think so, right? So for the first equation, you can write down as y equals 3 minus x. For the second equation, you can write down as x plus 1. Okay. And we can draw a picture. Sorry, draw a picture. One, two, three. So the first equation is 3 minus x. 3 minus x should be here. And if you pick x equal to 0, y equals 0, equals 3. If you pick y equals 0, x will be 3. So we get the first equation. It's a line goes through these 2 points. Okay. Now let's check the second equation. So x equal to 0, y equals 1 here. And when y equal to 0, x equal to -1. And of course, we can get the this line. Okay, this line. So this is the line is y equals x plus 1. Okay, so from this picture, you can see there is a intersection point. Intersection point. Okay, this intersection point corresponding to 1, 2. Did you see it? 1, 2 is the solution of these two linear equations. So that's the meaning of the solution of these two linear equations. Okay, we use a picture to show you what is the solution of these two linear equations. That is the intersections of these two lines. Okay. Now I want you guys try it. Another one by yourself. Try it by yourself. Solve it. Okay, did you get it? Please use the elimination, okay? Use the elimination. Some of you prefer the substitution, but in this class, I want you guys to use the elimination because in the linear algebra, there's a lot of elimination method. We call the Gaussian elimination. So you guys need to be very familiar with elimination method, okay? Okay, I'm gonna do it on board. So let's take a look. So for these two equations, 1 and 2, it's very clearly if I wanted to eliminate the y variable, here we're gonna see the coefficient for the first equation is -2, and here is 1. What are we gonna do? We let 2 multiply 2, right? So what are we gonna do? So we let equation 2 times 2, right? So we're gonna have times 2 for both sides. We're gonna get 2x plus 2y equals 6, right? Times 2 for both sides. 2x plus 2y plus equals 6. And then we can do the addition, right? Addition. So we're gonna get 1 plus 2, 1 plus 2. So x plus 2x is gonna be 3x. Okay. -2y plus 2y cancel out. That's what we want. Right? And of course, you can solve it. The first solution for the x is going to be 7/3. And we can plug in back to the first equation. We have, right, of course, here we have fraction. We can simplify it, move this term to the right-hand side. And this guy gonna be 3/3. Oh my gosh, hurricane. And -2y, -4/3 divided by -2, negative cancel out. Y equals 2/3. 2/3. Okay. And so the solution set gonna be 7/3, 2/3. That's it. That's it.